Hey everybody, this is Mr. Canfield. We're doing an Algebra 1 video today in polynomials and factoring. So we've already been through adding and subtracting. So today we're going to look at multiplication. All right, so I'm going to take you through these notes. Shouldn't take too long, and then I'm also going to walk through the practice page that I'm providing. And I'll make sure to have a copy of all my answers and everything so that you can look at that with the sub. So, all right, it says multiply a monomial and a trinomial. It says, what is the product of negative 4x cubed and x squared plus 3x minus 4? So product means multiply, right? So it's really saying, hey, negative 4x cubed times x squared plus 3x minus 4. And this was called, the way that we would multiply this was called the distributive property. We would take this negative 4x cubed and we would distribute it to each of the terms inside the parentheses. So we'd take this negative 4x cubed and we'd multiply it by each of these. It's fun to call these like the rainbow or whatever, draw the lines. The lines are just reminding us what we're doing. So you don't have to draw those lines. They're just showing you what you're doing. And then we're going to go through term by term and multiply each of these by this negative 4x cubed. So let's see, negative 4x cubed times x squared. So when I do these two, I'm really thinking, and so this is my thinking. I wouldn't write this down, but I'm saying negative 4x cubed times, there's no number there, 1x squared. And if you remember from our exponents unit, the way that we would do this is we would take negative 4 and 1. We would multiply those as we would normally do. And negative 4 times 1 is negative 4. So we get negative 4. And then we have x to the 3 and x to the 2. And remember, we add those exponents together. 1, 2, 3, 4, 5. X to the 5. So that's what those two get when we mush them together. Then we're going to multiply our next two, negative 4x cubed times positive 3x. So I'm thinking negative 4x cubed times a positive 3x. So same idea, negative 4 times positive 3 is negative 12. And so I'm going to write minus 12. If it's a positive, I'll write plus. If it's a minus, I'll write subtract. Then I have x cubed and x. And so we add these exponents, 3 plus blank, wait. Right, there's a 1 that's implied there. So 3 plus 1 is 4. X to the 4. Lastly, we'll do negative 4x cubed times negative 4. Remember, so this is what I'm thinking. If it does help to write these down, you can, but it's a lot of extra work that you don't need to show. Negative 4 times negative 4 is a positive. So plus 16. X cubed, there's no x's here. So a big difference between multiplying and adding is we can take negative 4x cubed times negative 4 and we can get positive 16x cubed. But if we bring this back and we say, wait a minute, what about negative 4x cubed minus 4? When we're doing adding and subtracting, we can only combine things together with like terms. So this actually doesn't change at all if we're doing adding and subtracting, but doing multiplication, we mush them together. So we have a couple of practices right here. If you haven't already, I would pause the video and try these. Don't just watch me do them, try them out. So I'm gonna do these in 3, 2, 1, 1. Wait, okay, so here we go. So I'll do the negative, I'm just gonna distribute. So negative 2x squared times x squared is going to be negative 2x to the 4th. The negative 2 times the 3 gets me a negative 6. X squared and the x gets me an x to the 3. And then negative 2 times positive 4 is negative 8. X squared and no x's, we're left with x squared. So that's what I get, and I'm done. All right, next one. Negative 4x, when I distribute this, negative 4x and then 2x squared, negative 4 times 2. You might notice we've used a negative every single time on these examples. It's because negatives trip people up. So we're doing this to really practice dealing with negatives. Not every problem is going to start with a negative like these do. It's just because of this situation, or sorry, the difficulty people have with negatives. So negative 4 times 2 is negative 8, and then x squared. Remember, that's a 1 there, so it's 1, 2, 3. There are 3 x's. And we do the same thing. Negative 4 times negative 3 is positive 12. We have an x to the 1 and another x to the 1. So x1, that's 2 x's total, x squared. Then negative 4x to the 1 and a 5. So negative 4 times 5 is negative 20. And x to the 1, no x's, x to the 1. Something that's worth noting, since we started out and multiplied by a negative sign in all 3 of these first examples, you might notice this was positive, positive, negative. The final answer was switched, negative, negative, positive. Every positive turned to a negative, every negative turned to a positive. Same thing down here. This negative changed all these negatives, all these positives into negatives. And here, this negative, this was a positive, negative, positive. It switched it to negative, positive, negative. It always does this. When we multiply by a negative, it changes every sign that it touches. So, all right, it says, what is the area of the rectangle? So the area of the rectangle, remember, the area of any rectangle is length times width, or base times height, depends on how you want to talk about it. So if I had a rectangle, and let's say we had a size of 6 and then a size of 7, the area of the rectangle would just be 7 times 6, right? Or 6 times 7. But instead, what if we had a strange situation here where we had a rectangle that had a side of 2x and a little 1 here, and so we've got these little blocks, and then x and a 3 here. Well, so we're going to do this in a couple of different ways. I'm going to show you using this little area model how we can find the area, and then we'll talk about the more traditional way that we find area. So, messed that up a little bit. Let's see. Okay. Wow, I really messed that up. Okay, let me try this again. All right. So here's our rectangle. And then we had our, so this was 2x, this was a 1. So this is a 1, this is a 2x. And then down here, this is an x, and this is a 3. So what we can do is we can actually find the area of the little mini rectangles inside here. And if you don't know what I'm talking about, I'm going to show you. So this rectangle down here, this little mini rectangle, let's talk about the sides of this rectangle. This is our length and our width. Well, our length is x and our width is 1. So we could really do 1 times x and just get that the area there is x. Well, what about here? How wide is it here? Well, it's 1, 2, 3. It's 3 wide, 1 high. We could do 3 times 1 and get that this is 3. So just a little bit bigger, just so you can see it a little bit better. So here, I did it again. Here, it was 3 blocks wide. It was 1 block high. That means that the area right here is 3. And the area here was 1 by x. So it was 1 times x is x. Then over here we had our 2x. Wait, so it's 2x tall. How wide is it? Oh, it's x wide, right? It's 2x by x. What's 2x times x? It's 2x squared. So we have 2x squared, we have x, we have 3. We just got to find out this last block. Well, how tall is this last block? It's 2x tall, and then, it's 3 wide. What's 2x times 3? 6x. So we could say that the total area of this big rectangle is the 4 little rectangles added together, also known as 2x squared plus 6x plus x plus 3. Hey now, we've got some like terms there. These two are like terms. So I'm going to say this is 2x squared plus 6 plus blank. Oh, no, careful, that's a 1. 7x plus 3. So I could say this is my total area. Some people love thinking about multiplication like this. Some people, they see this and they go, that's stupid and I hate it. That's fine. Everyone's a little bit different. So we're going to do 2 more using what we call the area model. Oh, I should say one more thing about this. We secretly just performed this. 2x plus 1 times x plus 3. You might have seen something like this before. So in case you're not understanding where I got this from, look at this. What's the side on the rectangle here? It's a 2x and it's a 1. So we could say it's 2x plus 1. What about over here? It's an x and it's a 3, so we can say it's x plus 3. This, when we multiply this out, this strange looking beast, when we multiply this out, we get 2x squared plus 7x plus 3. So we're going to move on and do our next examples. We're going to get to see this area in action again. So again, some people love this method. I'm going to show you guys a few different methods to do this. And in fact, I'm going to, instead of drawing it perfectly like they have it here, I'm just going to draw just a box. And you might have heard of a Punnett square. People actually like to deal with these like Punnett squares. We have a 2x and we have a 4. And I like to actually put the sign that this is, so it's a plus 4. I like to say it's plus 4. Then we have a 5x and a plus 2. So you're welcome to kind of do the Punnett square. And we're saying, hey, it's not drawn to scale. This is just effectively like, yeah, we're going to have the 4 different boxes. So let's go through and see what we get. So this little square here, this little rectangle, because it's not actually going to be perfect necessarily. Let's see, 2x and 5x. We can do 2 times 5 is 10, and the x times x gets us x squared. Then, let's see, we have a 5x and a 4. They're both positive, so 5 times 4 is 20, and it tacks an x on. And then, let's see, this box down here, it's a 2, and it's a 2x. So that's a 2 times 2 is 4, and it tacks the x on. And then here we have a 2 and we have a 4. So 2 times 4 is 8. So I didn't put any positives or negatives on any of these. Remember, we only need to put a sign if it's a negative inside this box here. So now if I were to write this in standard form, let's see, I have 10x squared. You know what? We could even combine like terms before we write this, but just for clarity, I'm going to write it all out once. So I get plus 20x plus 4x plus 8. A lot of times what people do is they'll find the like terms inside here. They'll go, ooh, I got 20x and I got 4x. Instead of writing that, we could have written that there are 24 x's. All right, let's look at the next one. So they do this nice looking area model like this, and they show it kind of to scale. Again, I'm going to do this not to scale. And I'm just going to put, okay, I got 7x and I got a 2. I got 2x and I got a 1. And if you don't like writing the pluses, don't write the pluses. You know, you could just leave them out. And just remember that everything's positive unless we say, oh, this is a negative, by the way. So you got 7 and 2. 7 times 2 is 14. X times x is x squared. So you can say 14x squared. Then down here we got a 7x and we got a 1. So we could say 7 times 1 is 7. So 7x. Then over here, 2 times 2 is 4. And then there's only one x between them. And then lastly, 2 times 1 is 2. So now, instead of writing this line here, I'm going to go, wait a minute, let's look for like terms. Well, I've got a 4x and a 7x, so I can combine those. 7 plus 4 is 11. So I can say 14x squared plus 11x plus 2. So, just to back up and to talk about these are us taking the binomial 2x plus 4 times the other binomial 5x plus 2 and multiplying it. You may have heard of a term called FOIL before. Yeah, that's a thing. All right, let's see. This would be 7x and a 2. Oh, it says 7x and a 2. What should we put there? Well, unless it's negative, we'll put a plus. If we saw a negative, we would put a minus. So 2x plus 1. So this was the answer, or the simplified version of what we would get if we multiplied 2x plus 4 times 5x plus 2. So, all right. And I mentioned that because we have an example here, 2x plus 4 times x minus 5. I'm going to do this problem in two different ways. I'm going to do this using our little Punnett square that we did before. And I know it's not really a Punnett square, because if you're in biology and you're learning about Punnett squares, you'll notice Punnett squares talk about the different possible traits that we might have in offspring. We're not looking at that. We're just multiplying polynomials. Honestly, far less interesting. But we have to get this down to be able to do other stuff in algebra. So that's why we're spending time on it now. So I'll say 2x and a 4. And it doesn't matter if I put the 2x and the 4 here or on the side, as long as the whole polynomial is here. And then x minus 5. Notice the minus 5, I put a negative out in front of that 5. So then when we multiply these, we'll see 2x and x for this first box. 2 times, oh, there's a 1 there, remember. So 2 times 1 is 2, x times x is x squared. Then you can go in any order. In each box, we just look at what's across from it and what's at the top of it. So 1x and a 4, well, 1 times 4 is 4. And there's an x there. And then here, we have a negative 5 and a 2x. So negative 5 times 2 is negative 10x. And we'll have to be careful when we're combining like terms later. And then negative 5 times 4 is negative 20. You might be noticing that these two that I'm putting diagonally from each other, they've been like terms every single time. This happens a lot, but don't expect it always has to happen like that. It doesn't necessarily have to look just like that. So that's why I'm not drawing more attention to it than just mentioning it here in passing. So let's see, let's combine any like terms. I see 4x and I see negative 10x. So remember, when we're combining those, we've got negative 10 and we've got 4. So which army is bigger, or which team is bigger? The negative 10, that's the bigger team. So when they're fighting each other and canceling each other out, we wind up, they both lose 4, but this one has leftovers. The negative has leftovers. After it loses 4, it still has 6 left over. So negative 6x is left over here. Oh, I should have put the 2x squared out front, and the minus 20. There, now it's in. All right, so this is one way to do this problem. Here is the other kind of more traditional way that people look at this problem, at this exercise here. What they'll do is they will use the distributive property, which that's all we're doing here. It's just a different way to organize it. And so they'll take the 2x. Oh, you're not going to work for me right now? They'll take the 2x and they'll distribute it to each term in the other parentheses. This is too light, isn't it? Let's see. How are you? Yeah, it's a little better. So they'll go 2x times x. What is that? Well, 2x times x is 2x squared. And then 2x times minus 5, well, that's negative 10, and then an x. And then they'll take the plus 4, and they will also distribute it. So plus 4 times x, that's a 1. So 4 times 1 is 4 times an x. And then plus 4 minus 5, a positive times a negative is a negative. And similarly, we can look for like terms. Well, I see a minus 10 here and a plus 4 here. Minus 10 plus 4, same spiel as before. We get 2x squared minus 6x minus 20. Same answer, different method. So people will call this foiling, and I'll show you why it's called foiling. I actually don't recommend foiling. Foiling can present problems when we don't have a specific situation. I would recommend thinking about it as using the distributive property, taking this one times each of the ones, taking the second one times each of the ones. When we're distributing, we just want to make sure that everybody gets the same thing. So I give this 2x to everybody over here. I give this 4 to everybody over here. When it's just 2 pair, like this, 1 pair and 1 pair, it's not as big of a deal. But later on, if you look later on in our notes, you're going to see we've got a bunch of things here. So FOIL won't work in these, but our box method and the distributive property, just like this, will work. So let's see. You know what? I think, yeah. I think we're going to stop after A and B here. So, and then we're going to move into our practice page. So A says 5x minus 4 and 2x plus 1. So if I'm going to do this, I can pick either one. I'll do the box for this one. I'll do the Punnett square for this one. And I'm going to do the distributive property for this one. So 5x minus 4, 2x plus 1. So if I'm going through and doing my work for this, I'm going to note that 5x gets multiplied by both of the things in the other parentheses. So 5x times 2x is 10x squared. And then 5x times 1 is plus 5x. Then I have a minus 4 times 2x and times a 1. So negative 4 times 2x. 4 times 2 is 8, and it's a negative. So negative 8x. And then negative 4 times 1 is minus 4. And then I just look for any like terms. This time they're in the middle. So I'll say 10x squared, and then, 5 and negative 8. So remember, the way to figure this out in your head is you go, which one of these is the bigger number? 8's the bigger number. So that means negative wins. And since because one's plus and one's minus, since they're opposite sides, they're going to be fighting each other. And so we're going to get a smaller answer than either of those. And we get the difference between those, which is 3. And then since 5 was, the pluses were the smaller team this time, the pluses lost and the minuses won. And then the 4 comes down. And then I'll do this last one with the little box. I can say, okay, I got 3x and I got a minus 5. Notice how I did 3x and minus 5 on the side this time. A lot of other times I did it on the top. There's a stray mark. Hopefully that'll work out for us. Let's see, 2x and a plus 4. So let's see, 2x and 3x times together. 2 times 3 is 6. And then xx is x squared. Then 2x and minus 5. Well, it's 2 times minus 5 is minus 10. And there's an x. Let's see, minus 5 and 4. That's minus 20. And then 3x and plus 4. That's a positive 12. So I'm going to make this a little plus so I don't get confused. Plus 12x. I'm just changing that stray mark into a plus so I don't get confused later. So now I'm going to combine like terms. Oh, this time the positive army wins out of these two like terms, right? Positive 12, negative 10. How many are left over after all the 10 are canceled? 2 left, so the 2 positives are left. So we have 6x squared plus 2x minus 20. All right, so you're allowed to do either one of these methods in my class. If you're not sure which one you like, I would try a few of both and see which one you're more comfortable with. And if you definitely hate one of them, try it a few times and see if after trying it a few times you still hate it. So we just covered a whole bunch of stuff, and there is more to do. We're going to see next class how we handle these guys. But for now, we're going to move on to a practice page that I made up for you guys. And I'm not going to do the whole thing, but I'm going to do part of it. I'm going to go through and do the odds of this. There's 26 questions, so no time but the present. Let's see. Here we go. 7.1 and 7.2 practice. What makes you laugh? Oh, fun. So if you want to answer that, you can. If you don't, you don't. So it says name each polynomial by degree and number of terms. So I'm going to go down and I'm going to name each of these by their degree first. So let's see, what degree is number 1? Well, remember that degree comes down to the highest exponent that we see. So number 1 would be a degree 2, and if you're not sure what that is, we might need to go look it up. But when the degree is 2, that was called a quadratic. Let's see, this one was degree, what's the biggest exponent? Degree 3, so we'd call this one cubic. This one, highest exponent, 3. This one's also a cubic. Then let's see this one, degree 3 again, also a cubic. And this last one, hey, this last one doesn't have any exponents. Remember, that means it has an exponent of 0. This one was called a constant. So now we have to talk about what kind of nomial they are. They're all going to have the root word nomial. 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 All right. So remember that the nomial just comes from how many terms it is. This is 1, 2, 3. 3. A trinomial. No, a trinomial, right? That was our word for that, trinomial. This one was 1, 2. It's a bicycle, a binomial. Then 1, 2, 3, another trinomial. And then 1, monomial. And then the last one, oh, only one term, also a monomial. All right. So, what's going on here? So now we're going to simplify a bunch of expressions. So just going to reiterate that we've done these before. These should be pretty okay, but I wanted to give you some practice. So let's see. If I'm trying this first one, let's see, 6r squared. Why don't we just use x's? Computer. So 6r squared minus 4r to the 5th minus 3. Nope, that's a 9. Oh, I'm putting myself to sleep. JK, I'm awake. Man, I'm so funny. All right, let's see. So minus 9r, wow, r to the 3rd, or r cubed. Let's see, 12r squared, 4r to the 3rd, 13r to the 5th. So remember, when there's parentheses, but there's nothing out front, when there's just this 1 out front, we can essentially drop the parentheses. They're not there. They're not going to do anything. The only time that changes is if there's a minus sign before a parentheses. All right, let's see, 11. So let's see, 6r squared. Do we have any other r squareds? Ooh, I have 12r squareds over here. So 6 and 12, they're both positive, so they're on the same team, so they join forces. So now we have a total of 18 r squareds. All right, next I'll look at my r to the 5th. Do I have any other r to the 5ths? Oh, I do. I have 13 of them, but this time they're on opposing forces. So we're going to lose some of them, and we're going to go down to 9 of them, and the positives win. So 9r to the 5th. And some of you are probably annoyed that I wrote this. I wrote this in the wrong order already. I could have tried to write this in a better order, but we'll do standard form on the next line. Let's see, I also have negative 9r to the 3rd and a positive 4r to the 3rd. So when I combine those like terms, the negatives win that fight, and they win by 5, so 5r cubed. So let's put this in standard form. So biggest exponent goes first, 9r to the 5th. Second biggest exponent goes next, that's r to the 3rd. And then last one was this. Wait, this doesn't have a sign on it. If it doesn't have something, remember, it's positive. There we go. And we're done. So let's see, 13. So I'm going to try to do a little bit better job and not have to write 2 different steps in 13. The only thing I am going to have to do, though, is rewrite this because there's a minus sign out in front of that. So our first one didn't change, but our second one, that minus sign, remember, when we distribute that minus sign, that's going to change every sign in there. So now when I combine like terms, let's see, what's the biggest exponent we see? The biggest exponent we have is n to the 3rd. So plus 13 n to the 3rd, minus 8 n to the 3rd. The 13 wins, so positive wins, and it wins by 5. 5 n to the 3rd. Let's see, next I see an n squared. I see an 8n squared and a negative 7n squared. So 8 positive wins by 1. So I can say plus 1n squared. And then I see a plus 3 and a plus 4. They're on the same team, so they join forces. We get 7. All right. So in this next one, 14x cubed minus 2x to the 5th, there's nothing besides a 1 out front, so I can just bring it down. 14x to the 3rd minus 2x to the 5th. But this one, this minus sign is going to distribute to both of those. Change to negative 5x squared plus 4x. Because it was a positive inside, the negative was outside, so it changes it to a negative. And then we'll distribute this negative to all three of those and get negative 2x to the fourth, a positive 4x, and a positive 6x to the fifth. This first step is crucial. It's easy to make silly mistakes if we don't go through and change signs as necessary. All right, let's see what's next. So now I want to look and see what's my biggest exponent. I see an x to the fifth. So I've got 6x to the fifths here. I've got negative 2x to the fifths here. So 6 and negative 2 together. Well, the 6 wins, the positive wins, and we lose 2 of them. So there's 4. 4x to the fifth. Let's see, do I have any x to the fourths? I do. I have a negative 2x to the fourth, but that's the only one. No friends, no enemies, just comes down. Let's see, do I have x to the thirds? Oh, I do. Again, no friends, no enemies. So, let's see, what about x squareds? Oh, I have an x squared with no friends or enemies. Okay. And then looks like we have 4x and then another 4x and their friends. They joined forces. And no constant term this time, no number. Well, there we go. So you might notice I did this a little bit differently than the box and buttons way that we've done before. I kind of did little underlines as I went to remind myself, hey, I've already looked at this. I don't need to look at this again. It's another organizational strategy. And then the back is just stuff that we were doing in class today. So, stuff that we were looking at for the first time today. So let me, I'll just go through and make sure that we're comfortable. So our first one has a 6 out front of this, so we just distribute that 6 to both of them. 6 times 5 is 30, and it has the R. 6 times 3 is 18, and it's still positive, so we write plus. Then 3 times 5n plus 1, 3 times 5 is 15, and 3 times 1 is 3. All right. Yeah, and I'm not going to spoil any of these because we need the practice. The best way for us to get better at this, not just understanding it, but doing the practice. So when you're practicing these, a key thing, they say practice makes perfect, but that's not true. And they say perfect practice makes perfect. That's okay. Nobody's perfect. Nobody is ever going to be perfect with these things. So what we want to do is we want to check ourselves as we go. Don't do the whole paper, then go check. Do the first couple, then go say, hey, am I getting these right? And if you're getting them right, great. Practice a bunch more. But if you're not getting them right, go back, figure out what's going wrong. Is it a silly mistake or is it something bigger? And then come back. Oh, and lastly, I will say, there are some of you that are going to get to a point where you're comfortable saying, oh, this is, 21 n squared, and then plus 29n plus 10. And you're going to jump to the final answer in one step. You're not going to do any work. This is perfectly okay, but if you're not getting it perfectly right, don't do it. This means, oh, I'm not ready to do this all in my head yet. I need to be making sure I'm showing my steps. And it gets kind of tricky. So just be careful. Hope this was helpful. And sorry I had to miss class today. See you soon. Bye.